3-foot clearance in front of electrical equipment is required for safety and accessibility. This clearance allows for safe operation and maintenance of the equipment, as well as access for emergency personnel in the event of an electrical fire or other emergency. In the described case, the use of bifold doors that open to provide the required 3-foot clearance is acceptable, provided that the doors are kept open when the electrical equipment is being accessed or serviced. The National Electrical Code, or NEC, does not specifically address the use of bifold doors in this situation, but it does require that electrical equipment be accessible. The use of bifold doors that can be opened to provide the required clearance meets this requirement. It is important to note that the doors must be kept open when the electrical equipment is being accessed or serviced. If the doors are closed, the clearance requirement is not met, and the safety and accessibility of the equipment is compromised. To ensure that the doors are kept open when necessary, it is recommended that a door holder or other device be installed that will keep the doors open when they are not being used. This will help to prevent the doors from being closed accidentally, which could create a safety hazard. The accessibility and working space requirements around electrical equipment are crucial for both safety and efficient operation. These requirements are detailed in the National Electrical Code, specifically Article 110.26, which outlines the necessary clearances and working spaces for equipment operating at 600 volts or less. The primary purpose of these clearances is to provide adequate space for electricians and other qualified personnel to safely and effectively perform maintenance, repairs, and inspections on electrical equipment. This includes tasks such as troubleshooting, replacing components, and taking measurements. Without sufficient working space, the risk of electrical shock, arc flash, and other injuries significantly increases. The 3-foot clearance requirement in front of electrical equipment is a critical component of these safety standards. This minimum depth ensures that there is enough room for a person to stand and work comfortably while maintaining a safe distance from energized parts. The width of the working space is also important and is generally required to be 30 inches or the width of the equipment, whichever is greater. This allows for lateral movement and prevents workers from being cramped or restricted while performing their duties. The height of the working space must be at least 6 feet 6 inches or the height of the equipment, whichever is greater. This vertical clearance prevents workers from hitting their heads on overhead obstructions and ensures they have adequate headroom to work safely. In situations where bifold doors are used to provide the required clearance, it is essential that these doors can be fully opened and secured in the open position. This ensures that the full 3-foot depth and required width are available whenever work is being performed on the electrical equipment. The use of door holders or other locking mechanisms is highly recommended to prevent accidental closure of the doors, which could compromise the working space and create a hazardous situation. It is also important to consider the specific layout of the electrical room or closet and ensure that the location of the equipment does not create any additional obstructions or hazards. For example, the equipment should not be placed in a location where it is difficult to access or where there is limited ventilation. Proper lighting is also essential to ensure that the working space is well lit and that workers can clearly see the equipment and any potential hazards. In addition to the clearance requirements, the NEC also specifies other important safety measures that must be followed when working with electrical equipment. These include the use of appropriate personal protective equipment, or PPE, such as insulated gloves, safety glasses, and arc-rated clothing. Workers should also be trained in proper lockout/tagout procedures to ensure that the equipment is de-energized before any work is performed. Regular inspections of electrical equipment are also essential to identify any potential problems or hazards before they can cause an accident. These inspections should be performed by qualified personnel and should include a thorough examination of all components, wiring, and connections. Any damaged or worn component should be replaced immediately, and any potential hazard should be addressed promptly. In summary, the 3-foot clearance requirement in front of electrical equipment is a critical safety measure that must be followed to protect workers from electrical hazards. When using bifold doors to provide this clearance, it is essential to ensure that the doors can be fully opened and secured in the open position. Proper lighting, ventilation, and the use of appropriate personal protective equipment are also important factors to consider when working with electrical equipment. By following these safety guidelines, the risk of electrical accidents can be significantly reduced. Now let's delve deeper into the nuances of electrical panel installations and the relevant National Electrical Code requirements. The NEC is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect the latest technologies and safety practices. Understanding and adhering to the NEC is crucial for anyone involved in electrical work. Regarding the specific situation of a 200 amp panel in an electrical room, several NEC articles are particularly relevant. Firstly, as previously mentioned, NEC Article 110.26 covers the working space about electrical equipment operating at 600 volts or less. This article details the required depth, width, and height of the working space, as well as other important considerations such as illumination and access. The depth of the working space, the 3-foot clearance being discussed, is determined by the voltage to ground of the equipment and the presence of any exposed live parts on the opposite side of the working space. For a 200 amp panel, the voltage to ground is typically 120 volts if it's a 120 or 240 volt system, or 277 volts if it's a 277 or 480 volt system. The required depth of the working space will vary depending on the specific voltage and the conditions present. Condition 1, as defined in the NEC, applies when there are exposed live parts on one side of the working space and no grounded parts on the other side. Condition 2 applies when there are exposed live parts on one side of the working space and grounded parts on the other side. Condition 3 applies when there are exposed live parts on both sides of the working space. The required depth of the working space is typically greater for Condition 2 and Condition 3 than for Condition 1. In the case of a 200 amp panel, Condition 2 is the most likely scenario as the panel enclosure is typically grounded. This means that a 3-foot clearance is generally required. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. This ensures that there is enough room for a person to stand and work comfortably. The height of the working space must be at least 6 feet 6 inches or the height of the equipment, whichever is greater. This prevents workers from hitting their heads on overhead obstructions. In addition to the working space requirements, NEC Article 110.26 also addresses the issue of access to electrical equipment. This article requires that there be adequate access to all electrical equipment to allow for safe operation and maintenance. The access route must be clear and unobstructed, and there must be sufficient space to allow workers to move freely around the equipment. In the case of an electrical room or closet, the access door must be large enough to allow workers to enter and exit the room easily. The door must also be capable of being opened and closed without obstruction. The use of bifold doors in this situation is acceptable provided that the doors can be fully opened and secured in the open position. This ensures that the required working space is available whenever work is being performed on the electrical equipment. It is also important to consider the location of the electrical panel within the room. The panel should be located in a place where it is easily accessible and where there is sufficient ventilation. The panel should not be located near any sources of heat or moisture, as this could damage the equipment and create a safety hazard. In addition to the NEC requirements, there may also be local codes and regulations that apply to electrical installation. It is important to check with the local authorities to ensure that all applicable codes are being followed. Another important aspect to consider is the proper grounding of the electrical panel. Grounding is a critical safety measure that helps to protect against electrical shock and fire hazards. The NEC requires that all electrical panels be properly grounded to a grounding electrode system. The grounding electrode system typically consists of a ground rod, a metal water pipe, or a concrete encased electrode. The grounding electrode system must be properly sized and installed in accordance with the NEC requirements. The grounding conductor must be connected to the grounding electrode system and to the electrical panel. The grounding conductor must be sized according to the size of the service entrance conductors. In addition to the grounding conductor, there must also be an equipment grounding conductor. The equipment grounding conductor is a separate conductor that runs with the circuit conductors and is connected to the metal enclosures of electrical equipment. The equipment grounding conductor provides a path for fault current to flow back to the source in the event of a ground fault. This helps to trip the circuit breaker or fuse and prevent electrical shock hazards. It is also important to ensure that all electrical connections are properly made and tightened. Loose connections can cause overheating and arcing, which can lead to electrical fires. All electrical connections should be made with approved connectors and should be tightened to the proper torque specifications. Regular maintenance of electrical equipment is also essential to ensure its safe and reliable operation. Electrical panels should be inspected regularly for any signs of damage or wear. Circuit breakers and fuses should be tested periodically to ensure that they are functioning properly. Any damaged or worn component should be replaced immediately. In summary, the installation of a 200 amp panel in an electrical room requires careful attention to detail and adherence to all applicable codes and regulations. The working space requirements of NEC Article 110.26 must be followed to ensure the safety of workers. The panel must be properly grounded and all electrical connections must be properly made. Regular maintenance is also essential to ensure the safe and reliable operation of the equipment. Now, let's discuss some additional considerations for ensuring safety and compliance when installing and maintaining electrical panels. One important aspect is arc flash protection. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in electrical equipment. The resulting explosion can cause severe burns, injuries, and even death. The NEC requires that electrical equipment be labeled with arc flash hazard warnings. These warnings provide information about the potential arc flash hazard and the personal protective equipment that is required to work safely on the equipment. It is important to follow these warnings and to wear the appropriate PPE whenever working on electrical equipment. Another important consideration is the proper selection and installation of overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices must be properly sized and installed in accordance with the NEC requirements. The size of the overcurrent protection device must be matched to the ampacity of the circuit conductors. The overcurrent protection device must also be capable of interrupting the maximum available fault current at the point of installation. It is also important to ensure that the overcurrent protection devices are properly labeled. The labels should indicate the ampacity of the device and the type of circuit that it protects. This information is essential for troubleshooting and maintenance purposes. In addition to overcurrent protection, it is also important to consider surge protection. Surges are transient overvoltages that can damage electrical equipment. Surges can be caused by lightning strikes, power outages, and other events. Surge protection devices, or SPDs, are designed to protect electrical equipment from surges. SPD are typically installed at the service entrance and the downstream panels. SPD must be properly sized and installed in accordance with the NEC requirements. It is also important to ensure that the SPD are properly grounded. Another important consideration is the proper identification of electrical circuits. All electrical circuits should be clearly identified with labels that indicate the purpose of the circuit. This information is essential for troubleshooting and maintenance purposes. The labels should be durable and easy to read. It is also important to update the labels whenever changes are made to the electrical system. In addition to labeling, it is also important to maintain accurate electrical drawings. Electrical drawings provide a detailed representation of the electrical system. These drawings should show the location of all electrical equipment, the routing of all conductors, and the size and type of all overcurrent protection devices. Electrical drawings are essential for troubleshooting and maintenance purposes. The drawings should be kept up to date and should be readily available to qualified personnel. Regular training is also essential for ensuring the safety of workers who work on electrical equipment. Workers should be trained in the proper procedures for working on energized and de-energized equipment. They should also be trained in the use of personal protective equipment and in the identification of electrical hazards. Training should be provided by qualified instructors and should be updated regularly. In summary, ensuring safety and compliance when installing and maintaining electrical panels requires careful attention to detail and adherence to all applicable codes and regulations. Arc flash protection, overcurrent protection, surge protection, circuit identification, electrical drawings, and worker training are all important considerations. By following these guidelines, the risk of electrical accidents can be significantly reduced. Furthermore, let's discuss the specific requirements for electrical rooms and the environment in which electrical panels are installed. The NEC has specific requirements for electrical rooms to ensure safety and proper operation of equipment. Firstly, adequate ventilation is essential. Electrical equipment generates heat, and proper ventilation is necessary to prevent overheating, which can lead to equipment failure and potential fire hazards. The NEC requires that electrical rooms have sufficient ventilation to maintain the equipment within its rated temperature limits. This can be achieved through natural ventilation, such as louvers or vents, or through mechanical ventilation, such as fans or air conditioning systems. The specific ventilation requirements will depend on the size and type of equipment installed in the room, as well as the ambient temperature of the surrounding environment. Secondly, proper illumination is crucial. Adequate lighting is necessary to allow workers to safely and effectively perform maintenance and repairs on electrical equipment. The NEC requires that electrical rooms have sufficient illumination to provide a safe working environment. The specific illumination requirements will depend on the size of the room and the type of work being performed. In general, a minimum of 10-foot candles of illumination is required at the working surface. Emergency lighting should also be provided in case of a power outage. Thirdly, environmental control is essential. Electrical equipment is sensitive to moisture, dust, and other contaminants. The NEC requires that electrical rooms be protected from these elements. The room should be kept clean and dry, and measures should be taken to prevent the entry of moisture, dust, and other contaminants. This can be achieved through proper sealing of the room, the use of air filters, and regular cleaning. Fourthly, dedicated space should be considered. Electrical rooms should be dedicated to electrical equipment and should not be used for storage or other purposes. This helps to prevent the equipment from being damaged or obstructed. The room should also be kept clear of combustible materials. Fifthly, physical protection is important. Electrical equipment should be protected from physical damage. The room should be constructed of durable materials and should be designed to withstand the stresses of normal operation. The equipment should also be protected from accidental contact by unauthorized personnel. Sixthly, access control is a factor. Access to electrical rooms should be restricted to qualified personnel. This helps to prevent unauthorized access and reduces the risk of accidents. The room should be secured with a lock and key, and access should be controlled by a designated individual. Seventhly, signage and labeling is important. Electrical rooms should be clearly marked with appropriate signage and labeling. The signage should indicate the purpose of the room and any potential hazards. The equipment should also be labeled with its voltage, amperage, and other important information. Eighthly, fire protection should be implemented. Electrical rooms should be equipped with appropriate fire protection equipment. This may include fire extinguishers, fire alarms, and automatic sprinkler systems. The specific fire protection requirements will depend on the size of the room and the type of equipment installed. In summary, electrical rooms should be designed and constructed to provide a safe and suitable environment for electrical equipment. Adequate ventilation, proper illumination, environmental control, dedicated space, physical protection, access control, signage and labeling, and fire protection are all important considerations. By following these guidelines, the risk of equipment failure in electrical accidents can be significantly reduced. Finally, let's address some common misconceptions and frequently asked questions about electrical panel clearances and working space. One common misconception is that the 3-foot clearance requirement is only for large electrical panels. In reality, the 3-foot clearance requirement applies to all electrical equipment operating at 600 volts or less, regardless of size. This includes small panels, disconnect switches, and other electrical devices. Another common misconception is that the 3-foot clearance is only required in front of the equipment. In fact, the clearance is required in all directions, including the sides and rear of the equipment. This ensures that workers have adequate space to move around the equipment and perform maintenance and repairs. Another frequently asked question is whether the 3-foot clearance can be reduced if there are no exposed live parts. The NEC allows for reduced clearances in certain situations, but only if specific conditions are met. For example, the clearance can be reduced if the equipment is enclosed in a grounded metal enclosure and there are no exposed live parts on the front of the enclosure. However, even in these situations, the clearance must still be sufficient to allow for safe operation and maintenance. Another frequently asked question is whether the 3-foot clearance is required for residential electrical panels. The NEC applies to both residential and commercial electrical installations. Therefore, the 3-foot clearance requirement applies to residential electrical panels as well. Another frequently asked question is whether the 3-foot clearance can be obstructed by other equipment or materials. The NEC prohibits the obstruction of the working space around electrical equipment. This means that no other equipment or materials can be placed within the 3-foot clearance zone. Another frequently asked question is whether the 3-foot clearance can be provided by a retractable or removable barrier. The NEC does not specifically address the use of retractable or removable barriers. However, in general, these types of barriers are not considered to be an acceptable substitute for the required clearance. The clearance must be permanently maintained at all times. Another frequently asked question is whether the 3-foot clearance is measured from the front of the equipment or from the enclosure. The clearance is measured from the front of the equipment. This means that the clearance must be maintained even if the equipment is recessed into a wall or enclosure. Another frequently asked question is what happens if the 3-foot clearance requirement cannot be met due to space limitations. In these situations, it may be necessary to relocate the electrical equipment or to use smaller equipment. It is also possible to apply for a variance from the local electrical inspector. However, variances are not always granted and should only be considered as a last resort. In summary, understanding and complying with the electrical panel clearance and working space requirements is essential for ensuring safety and preventing electrical accidents. The 3-foot clearance requirement applies to all electrical equipment operating at 600 volts or less, regardless of size or location. The clearance must be maintained in all directions and cannot be obstructed by other equipment or materials. If the clearance requirement cannot be met, it may be necessary to relocate the equipment or to use smaller equipment.